Hello. Now we'll discuss about the slicing iterables, right? We have been discussing about the iterables and the iterators and the generators, right? Now let's see how to slice the iterables. We have already done this. We have already sliced the list object. So consider that this is the list object we have. To slice it, we can simply use the square bracket. We can pass the start and the end index, like start and the end value, right? And then here you are able to slice the list. You can even use the slice object, right? So here we are getting the slice object. We are passing 0 to 2, right? And then we are passing this object to the list, and this will give me the 0th and the first element. But this does not work with the iterables that are not a sequence type. That means if the iterables are generated, let's see how this behaves. Like here, we are creating the factorial function, which is just the generators. This is the generators now, because instead of return this gives you the yield statement, right? Now again, here we are creating the fact of the factorials from the factorial generator. So fact is the generator now. And when we do fact 0 colon 2, we are getting error. That means we cannot slice the generator directly, but we can mimic the slicing, right? We have the more appropriate tools for that. But let's create this function. So we have this slice underscore, which takes the iterable start and the stop and try to give you the sliced version of the output or the sliced data from the generator, right? So here we are using the slice underscore. Now we are passing the factorial of 10. We are creating the generator object. Now we are passing 1 to 5. So we want to start at the 5 and stop at, so we want to start at 1 and stop at 5. And because this is the generator, the slice itself is a generator. So to reveal the value, we have to convert this to a sequence data. We are converting to a list. When we run this, we can see that, right? But this does not support the step value. Now, in the iter tool, we have the function called itSlice, which implement or which does this for us, right? So let's see how the itSlice works. First, here we have this factorial of 10, and again to get the value, we can convert this to a list. So here we have this factorial of the value between 1 to 10, right? So here we have calculated the factorial. Now let's use the slice functions to obtain the first three elements. So again, now we already know the output. Now we are trying to use how the slice function works. So first we need to import this slice function from the iter tools, right? And now we are using this slice function. We are passing this generator object. We are passing the start and the stop value 0 and the 3. So it should get 0, 1 and 2 index. So it should get 1 and 2 as an output. We should get this output if this works, right? But instead we are getting the iterators dot each slice object. So basically this is again a iterator now. So this each slice itself return you the iterator object, and this factorial is itself is the iterator, right? So again, it's a lazy iterator. That means it does not calculate directly the value. You have to take this in a loop, or you have to convert it to a sequence data. So here we are using the list to convert the value, and now we can see what, so we are getting the expected output. We can even use the step value over here. So we are using the step value as 2, and when we do this, we are getting the all the value over here. We can see that 1 2 4, like 1 2 24 7 20, right? All this value we are seeing, right? Now this does not support the negative indexing, but this does support the none. Like over here we are passing none, none and 2. This means that the start and the index is not known, but the step value is 2. So it will automatically consider the start value is 0 and the step value till it goes, and then we, so again like the, so the stop value till it goes to the total length, which is 10, and the step value will be 2. So it will automatically do and give you the output for you. Now we have this function which is very much helpful, which is very much useful when dealing with the infinite iterator. Here we have this factorial, right? We are starting the index as 0, and every time, right, when we calculate it, every time it gives you the, so every time it kind of calculate the factorial of the index, right, and store its own self. So right, so it's the yield object, right, and then we are incrementing the index. So every time when we call this factorial, or like every time when we call this generator, it will give you the next factorial value, and this will go till infinite because there is no boundation over here. Let's run this. Now we have created the object of factorial. Here the fact is, and when we take this in a for loop and try to run this in a 5 time, and remember, to get the output we have to call the next functions, right? When we run this, here we are getting the output, right? We can even use the each slice functions. We are saying that we want to, so here we have passing the function and then we are passing the 5. So we want to get all the value from 0 to 5, right? So here is the value we are getting, right? Again, we know that each slice is the lazy iterator, right? Now, here we can also see that. Now, what we are saying that since this each slice is the lazy iterator, that means when we use the step value, that means this third argument, right? So Python still calls next function to all the iterable. It just not like it just does not calculate only the value which is on the step value. Basically, it calculates all the value, even though we do not require that value. Let's see that in an action. So here we have just tweaked this factorial function, and before giving any output, we are printing this yield factorial with the index. Let's see that. Now when we do that, so here we are using each slice, and now we are passing, here we are giving this 9. That means we want to get the value from 0 to 8, right? Here, what we are saying is every time it is calling factorial 0, 1, 2, 3 till 8, and then we are getting the output. So this is working fine, but consider this example over here. Here, none is the start value, 10 is the stop value, and 2 is the step value. That means we want to get the output of 0, 2, 4, 6, 8, right? And the factorial of that index should be calculated. But when we run this, what is happening? Though we have got the output of 02648, 02648, right? So this is the total factorial we are getting. But though we are only getting the part of the output, but we are still calculating all the factorial value over here. We can see that, right? We can see that we are calculating all the factorial value because we are printing all the value, right? Even though if you are using with the each slice, it also works the same way. Like here, we are only skipping. So the start value is 5 and the stop value is 10. So we are not calculating between 0 to 4. Even though we do this, it has to calculate all the number from 0 to 10. We can see that, right? So this is how the lazy iterator work, right? Now other thing to see that this each slice is the iterator itself, which means that it become exhausted even if you pass the iterables such as list. Like over here we have this list. Now we are creating the slice object. We know that it is the iterator object, right? And when we pass this in a list of s, here we're passing this in a list of s, right? What value we are getting? We are getting 1, 2, 3, right? Now, because this is the iterator, right? So we have to convert this to a list. Now, when we again call the same object, because this is the iterator object, so it gets exhausted. When we again call this, we'll get the here we'll get the empty list. That means we are no longer getting the output, right? So we have to keep this in our mind. Now since slice iterate over the iterables, right, in order to yield the appropriate value, this means that if you use the iterator, that iterate will get consumed, right? Like over here we are using, like this factorial is itself the iterator over here, right? So we are creating this factorial. This is the fact. This itself is an iterator, right? Now we are using next to get the next value. Here we are calling the next 4 times. That means we'll get the 4 value, 1126. We are calculating 0, 1, 2, 3. So all this index value has been calculated. Now when we use this is slice, and now we pass this same object. Here we are passing the same object, we are passing 0 to 3. Here we are saying that we want to get all the value from 0 to 3. That means we want to get the value 1, 1, 2. But this will not work. So of course it will work, but will not get the same output. Why? You see that we have calculated the factorial of 4, 5, 6 because 0 to 3 has already been consumed. So the next value, next three value will be calculated. And then so here we are getting the output as it is, right? So we have to remember that, right? When you are like when we are using the generator, right? Again, even though if you'll say next fact, this will calculate the factorial of 7, right? Which is the value we are getting, right? So just we have to keep in mind that when we pass the iterator to its slice, right? So this will work, right? So like this will behave. So because this internal iterator will behave in this way. And actually in the iter tool, like approx all the function behave like an iterator, right? So we have to keep this in a mind, right? And this is it. This is all about slicing iterables. Thank you very much.